Hello, this is Daniel, and today I'm going to continue reviewing the journal On a New Kind of Rays by Wilhelm Conrad Röntgen, published in Nature in 1896 in volume 53, number 1369. If you didn't watch the first two videos, go watch them first because I'll be continuing from where we left off in the previous videos. Then, let's get started. Okay, so after discussing the differences between the cathode rays and X-rays, asserting that X-rays are produced from the cathode rays at the glass surface of the tube, Röntgen moves on to justifying how X-ray is a type of ray by illustrating how he could get the shadowed photograph of a hand by using X-rays. This picture here. He placed the discharge tube on one side of the hand and the photograph plate on the other, and then he lists other objects such as the compass, card, and needle or a piece of metal, and other objects that he also obtained the photographs of using X-rays to justify that X-rays is a type of ray. Then, Röntgen clarifies a potential question. What then are these X-rays? Because he mentioned that X-rays are not cathode rays, the audience may suppose that X-rays are UV lights, or ultraviolet lights in other words, due to their power of exciting fluorescence and chemical action. However, Röntgen challenges this idea by listing properties that X-rays should have if they are UV lights. These properties, A, B, C, D, are those properties. If X-rays are indeed ultraviolet lights, then that light must possess the following properties. It is not refracted in passing from air into water, called carbon bisulfide, aluminum, rock salt, glass, or zinc. It is incapable of regular reflection at the surfaces of the both bodies. It cannot be polarized by any ordinary polarizing media, and the absorption of various bodies must depend chiefly on their density. Since X-rays are not behaving according to those properties, the author implies how X-rays are not UV lights by mentioning that if X-rays are indeed UV light, then those ultraviolet rays must behave quite differently from the traditionally known ultraviolet rays. Röntgen then hypothesizes that X-rays are another type of light rays formed through longitudinal vibrations, not transverse vibrations. Lastly, Röntgen concludes that although he became familiar with X-rays in the course of this research, his hypothesis needs more supporting evidence and foundation, wrapping up his journal On a New Kind of Rays at last. So this was the third and last part of Röntgen's paper about the real-life application of X-rays, such as the photograph taking, and the potential hypothesis that X-ray is another type of light ray produced from longitudinal vibrations. Thank you for following my journey through Wilhelm Röntgen's On a New Kind of Rays journal review. See you in my next videos. Bye.